What's up guys, and welcome to this tutorial on question 4 of the 2017 supplementary exam. We are going over Newton's laws. Okay, so let's get straight into the question. Two identical blocks A and B are connected by a light inextensible string that passes over a frictionless pulley as shown in the diagram. Each block has a mass of 2 kilograms. Initially block B is resting on the ground while block A is 4 meters above the ground. So you can say it's got a height of 4 meters. Okay, so a block of mass 1 kilogram is placed on top of block A. So we have a 1 kilogram block placed on there, and the system accelerates as a result. Okay, and this makes sense. Okay, so if we look at the system, we can see that on the left we have, let's see, what's a nice color. On the left we have 3 kilograms, and on the right we have 2 kilograms. Okay, so obviously this system is going to move something like this. It's going to move counterclockwise. Block A is going to move down, and block B will move upwards. Okay, so question 4.1. It says draw a labeled free body diagram of the forces acting on B after it has left the ground while accelerating upwards. Okay, so it's already told you that the system is accelerating upwards, or B is accelerating upwards, and then it says the relative sizes of the forces must be clear. Okay, so all this last sentence means is that arrows indicate magnitude. Okay, so the length of the arrows must indicate the magnitude of the forces. Okay, so we're going to look at block B, and they want a free body diagram. So block B, just after it's left the ground, there's weight acting. Okay, and we also know that there is a tensile force which is greater than weight. So I'm actually going to draw it a bit longer. There we go, and we can say that is tension. And then if we want to make it really clear, we can put on the side there that tension is greater than weight. Okay, and that's the case because we know that block is moving upwards, and we get 3 marks for that. Question 4.2 is a definition. It's quite a long one, and my handwriting is not that great, so I'll just give it to you guys. But basically, Newton's second law of motion says that when a net force is applied on an object, the object accelerates in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass. Okay, so from this definition, we get the equation F net equals mass times acceleration. Okay, and we get 2 marks for that long definition. Okay, then question 4.3 says calculate the magnitude of the acceleration of this system. Okay, so right now I have a free body diagram for B. I'm going to start off by doing a free body diagram for A. Okay, so the free body diagram for A is going to look something like this. So by A I mean A, let's say, plus the extra 1 kilogram mass. Okay, so in the system A, I'm including the 1 kilogram mass. So what we have is we're going to have the weight, okay, is going to be greater than the tension this time. Okay, because we know it's going downwards. Okay, now what I'm going to do is write Newton's second law for that. So F net equals the mass of A times the acceleration of the system. Okay, so the net force I'm going to take as down as being positive because I know that block A will be moving downwards. So we have weight minus tension is equal to mass of A times acceleration. Okay, so the weight here is going to be our weight of the left hand side, which is 3 kilograms. 3 times 9,8, because weight equals mass times gravity, minus the tensile force is equal to the mass 3 times the acceleration. Okay, so this equation has 2 unknowns, T, the tension, and the acceleration. So now I'm going to look at block B. Okay, so for block B, I want F net is equal to MA once again, but because my free body diagram, because it moves upwards, I'm going to take upwards as being the positive direction for this. So the net forces here is going to be tension, which is positive, minus weight is equal to mass of B times acceleration. Tension is an unknown, weight is going to be our mass times gravity, which is 2 times 9,8 is equals to our mass, which is 2 times the acceleration. Okay, I'm going to label this equation 1 and this equation 2. Then what I'm going to do is I'm going to write equation 1 as it is. Okay, so that's equation 1. Then equation 2, I'm just going to change the order of it a little bit. It's just going to be minus, okay, plus the tension is equal to 2 times acceleration. That's the same equation. And then what I'm going to go is I'm going to try get rid of the t's. So I'm going to go equation 1 plus equation 2, which will give me equation 3. Okay, so I'm going to add these, so then I'm left with 9,8. The t's cancel is equal to 5 times the acceleration. Okay, there's only one unknown here, which is the acceleration, and the acceleration equals 1,96 meters per second squared. And we'd ask for the magnitude, and we get 5 marks for that. So we don't, because it asks for the magnitude, we don't care about the direction. Okay, and we get 5 marks. Then question 4.4 says calculate the tension in the string joining block A and B while they're accelerating. So I'm looking for the tension. So I'm going to take equation 1, and so that's 3 times 9,8 minus t is equals to 3 times the acceleration, which I just calculated. So the acceleration is 1,96. Okay, the only unknown now is t, so I can solve for t, which is equal to, t is going to be 23,56 newtons, and that's the answer. Okay, it doesn't ask for a direction, because on the left hand side, so for block A, the tension would be up, so for block A, tension would be upwards, and for block B, tension, for block B, so for block A it's upwards, and for block B it would also be upwards. Okay, so both of them are actually upwards, so we could have actually put upwards in there, but we don't need to. Okay, so we get 2 marks for that. Okay, so so then the question goes on and says block A hits the floor with a speed of, so velocity of 3,96 meters per second and comes to rest almost immediately. Okay, so it says question 4.5, determine the resultant force acting on block B just after block A has reached the floor. Okay, so once block A reaches the floor, the resultant force is going to be the weight. So the force is going to be weight, which is mass times gravity, which would be the mass of block B, which would be 2 kilograms times 9,8, which is equal to 19,6 newtons. And that's the answer there. Okay, so question 4.6 is a definition, which says define mechanical energy. Okay, so what is mechanical energy? Mechanical energy is the sum of the gravitational potential energy and the kinetic energy at a point. Okay, so basically the equation we get out of this would be the equation EMEC, which stands for mechanical energy, equals EK kinetic energy plus EP potential energy, okay, at a given point. So question 4.7. Okay, for the definition, you only need to include that part right there, but knowing that this is the equation is going to be quite useful, as we will see. We get 2 marks for the definition. Okay, so question 4.7 is a bit of an explanation. So it says, explain why the conservation of mechanical energy may be used to calculate the maximum height reached by block B. Okay, so explain why we can use conservation of mechanical energy. Okay, so because it is a frictionless pulley and there are no we're going to assume that there's no air resistance or friction or any of that. So we can say the reason why we can use the mechanical energy, conservation of mechanical energy, is because there are no external forces or friction acting on block B once block A hits the ground. Yeah, cool stuff. And we've got one last question, which is question 4.8. Okay, so question 4.8 says, use the conservation of mechanical energy to calculate the maximum height from the ground reached by block B. So we want to know the maximum height reached by B. Okay, so an important thing to realize is that A and B will always move at the same velocity. Okay, so A and B have the same velocity at any point. Okay, and why is this? Because they're connected by a rope. So if you try this at home, connect 2 things by a rope. If you pull one side, the other one will move at the same velocity. Okay, so what we know is that when A hits the floor, it has a speed of 3.96. So when A hits the floor, its velocity equals 3.96. That means that when B reaches 4 meters, so when B is here, so when this is B, it has a velocity of 3.96. So basically we can do a conservation of mechanical energy from this point here. So we're going to call this our, okay, let's actually clean this up a little bit. So we can call this our datum point, okay, and work from there. So we can say that for question 4, EMEC at the, let's call this datum the bottom, and wherever it ends up, the top for B. Okay, so EMEC at the bottom equals EMEC, so mechanical energy at the top, let's just say T and B. Okay, so at the bottom we have EP, potential energy at the bottom, plus EK at the bottom is equal to EP at the top, plus EK at the top. Okay, but we know that at the bottom, we're taking that as the datum. So at the bottom, this goes to 0. And at the top, we wanted to reach a maximum kinetic energy. So maximum height, so kinetic energy must also equal 0. So then what we left is mgh at the, sorry, this is the datum one, so EP goes to 0 here and EK goes to 0 there. So what we actually have is half mv squared at the bottom is equal to mgh at the top. Okay, so half the mass of B would be 2 kilograms times the velocity, which is 3.96 squared, is equal to the mass times gravity times height at the top. Okay, the only unknown here is our height, so we can solve for the height, and the height equals 0.8 meters. Okay, so what we know is that at the top, we know it gets to 0.8 meters. Okay, so but the question asks the height from the maximum height from the ground. Okay, so from the ground, it would be that total height, this total height right here, that height there, which would be, so height would equal the height to here, which is our 4 meters, plus 0.8, which is equal to the final height of 4.8 meters. And that would be our final answer, and we get ourselves 4 marks for that. Okay, so a nice, interesting question, not too long, not too short, but yeah, a couple of definitions in there. So I hope you guys found all the explanations quite useful, and yeah, thanks for watching, guys.